Welcome to the final and perhaps the most pivotal stage of scientific inquiry, data interpretation. This stage is where the collected data, the raw numbers and observations, are transformed into meaningful insights. Let's journey into how scientists make sense of their findings and uncover the stories hidden within data. Imagine an ecologist studying the effects of climate change on plant growth patterns. For years, they've collected data on various plant species, their growth rates, flowering times, and seed production. This data, while extensive, is a jumble of numbers and dates. The ecologist begins the task of data interpretation by organizing this information into tables and graphs. Patterns start to emerge. They notice that flowering times are shifting earlier in the year, a trend that aligns with rising temperatures. This visual representation of data is more than just charts. It's a window into the subtle impacts of climate change on plant life. In another scenario, a medical researcher is analyzing data from a clinical trial for a new drug. They have data on patient recovery rates, side effects, and dosage amounts. Through careful analysis, using statistical methods, they seek to answer critical questions. Is the drug effective? What's the optimal dose? Are there any significant side effects? This analysis is crucial. It determines not just the future of the drug, but potentially the well-being of thousands of patients. Data interpretation in science often involves looking for correlations, patterns that might indicate a cause and effect relationship. A marine biologist, for instance, might analyze data on ocean temperatures and fish migration routes. Are the fish moving to new areas as the water warms? This correlation can provide insights into how climate change is impacting marine ecosystems. But interpreting data isn't just about finding patterns, it's about drawing conclusions and sometimes raising new questions. It involves critical thinking and often a bit of detective work. Scientists must consider not just what the data is showing, but what it means. Is the trend significant? Does it support or refute the initial hypothesis? Are there alternative explanations? Data interpretation is the culmination of the scientific method. It's where hypotheses are confirmed or challenged, where theories are shaped, and where new questions arise. This stage is essential in advancing scientific knowledge, providing the foundation for future research and exploration. As we delve into the world of data interpretation, remember that it's a dynamic and often complex process. It's a blend of science and art, requiring not just technical skills, but also creativity and intuition. Join us in this exploration, where data becomes knowledge, and knowledge leads to understanding.